use Descartes' rule of signs and the rational zero theorem, everything we can to find all the zeros. Now I'm looking at this and I see one sign change. Now one sign change basically tells me there is one positive real zero. So I might as well start looking for that one positive real zero. Now let's finish off Descartes' rule of signs. Let's look at s of negative x. When I substitute a negative into x to the fourth, it just becomes x to the fourth. When I substitute a negative in and cube it, I get a negative x cubed times 5, so that's negative 5x cubed. Substitute a negative into the next term, but square it, it stays positive, so plus x squared. A negative x times negative 21 makes plus 21x minus 18. So I see 1, 2, 3 sign changes, and that means 3 sign changes. And that applies, there are 3 or 1 negative real zeros. Negative because that's what we found when we substituted the negative x in. Now this does not give us the zeros, it just tells us where we might look. So that's the first part. Now let's look at our function again. We've got s of x equals x to the fourth plus 5x cubed plus x squared minus 21x minus 18. The rational zero theorem helps us to identify what those zeros might be. The leading coefficient is 1 and only has a factor of 1. But the 18 there has factors of 1, 2, 3, 6, 9, and 18. And when we put the factors of the constant to the right over the factors at the left, we have the following possible rational zeros on the following list: plus or minus 1, 2, 3, 6, 9, or 18. Now we could try and narrow those down by using the upper or lower bound theorem, but I'm not going to. I'm just going to start moving right in with this. Let's begin now by trying the test for 1, whether it is a 0. And that means adding these coefficients together. 1 plus 5 plus 1 minus 21 and minus 18. That's a lot of negativeness, so that is not going to add up to 0. Let's try it for negative 1, and that means changing the sign on the odd degreed terms. So we would have 1 minus 5 plus 1 plus 22 and minus 18, and this does add up to 0. So we know that negative 1 is a 0, and we should start our synthetic division looking at that point. So here we go with negative 1. Our polynomial is 1x to the fourth, 5x cubed, 1x squared, minus 21x, and minus 18. And I'm going to start the problem right there all over again. Draw our line, bring the 1 down. Negative 1 times 1 is negative 1. Add down in the next column to get 4. Next column we get negative 4. Add down to get negative 3. Negative 1 times negative 3 is positive 3. Add to that and get negative 18. And everything's going to zero out just as we were told. So s of x can now be written as x plus 1. That's changing the sign from the negative 1 that we just had there, times, next parentheses, x to the third plus 4x squared minus 3x minus 18. Now we keep factoring again. We know that negative 1 or 1 won't work. Negative 1, let's try it again. If we change these two signs and add, that's not going to work. So we need to continue on with our synthetic division, and it's time now to try some more numbers. Let's try 2 as a starting point. So we've got 1, 1, 1, 4, negative 3, negative 18. Bring down our 1. 2 times 1 is 2, plus that 4 makes 6. 2 times 6 is 12, minus that 3 makes 9. 2 times 9 is 18, minus 18 is 0. We got lucky very quickly here. So here we go. S of x is equal to x plus 1 times x minus 2, we change our sign, times x squared plus 6x plus 9. Okay, that's going to factor at the end there. So we have x plus 1, x minus 2, times x plus 3, quantity squared, and our zeros are the following. We have -1, +2, and -3, and that -3 has a multiplicity of 2.